Okay, so final video. What we're going to do in this video is we're going to be able to find something called the nth root of unity. So what does that mean exactly? Well, if I'm asked to find the third root of unity, you're basically being asked to solve the equation z cubed equals 1. Okay? Unity being, one unit, 1. Okay? So, if you're being asked to find the 10th root of unity, then you're being asked to solve the equation z to the power of 10 equals 1. Okay? So I hope that makes sense. And so if the question asks you to find the roots of unity, that's what we mean. Okay? So we're already good at doing that. We've done that in the past videos. Okay, so let's just have a look at this question here. It says find the fifth roots of unity and display them on an Argand diagram. So it's basically asking us to find z to the power of 5 equals 1. Okay, so again, let's show 1 on an Argand diagram that has a modulus of 1 and an argument of 0. So or 2k pi, where k is any integer. So I'm going to rewrite this as z to the power of 5 equals cosine of 2k pi plus I sine of 2k pi. Using demoivre's theorem, z is equal to cosine of 2k pi over 5 plus I sine of 2k pi over 5. Okay, subbing in z equals 0, we will get cosine of 0 plus I sine of 0, which is 1. Okay, so we know we've got one solution at 1. Okay, let's find the others when we're going to be subbing in different values. Okay, so if we sub in 1, we're going to be doing cosine of 2 pi over 5 plus I sine of 2 pi over 5. For that, we'll need a calculator. Okay, so let's do, sorry, 1 second. Cosine of 2 pi divided by 5 equals about 0.309 plus sine of 2. We need to do sine of 2 pi divided by 5 equals 0.951i. Okay. Now, I'm just going to write it down over here, 0.309 plus 0.951i, but I'm also going to write it down in cis form, so it's going to be cis 2 pi over 5, okay? And I hope you can see that actually in cis form, each one of them is going to be just multiplying 2 pi over 5 by 2, basically. So it's going to be 4 pi over 5. Z4 is going to be cis 6 pi over 5. And Z5, remember there's 5 roots, it's going to be cis 8 pi over 5. No point in going to 10 pi over 5 because then you're back to the beginning anyway. Right, now, that might be useful in a bit. Do you know what? I'm not really going to actually waste time to find the other roots because you know how to do them. I don't want to waste your time. So you're going to use your calculator to find out what these values actually are. Sorry, let me put them back in. Just deleted them. 0.309 plus 0.951i, which is cis 2 pi over 5. Okay, you can use your calculator to work out what these missing ones would be, and then check them on an Argand diagram and check that the 5 solutions are equally spaced around the Argand diagram. And that's how you'll know you've done it right. Okay. Now, let W be the root with the smallest positive argument. Well, which one is the root with the smallest positive argument? If you've bothered to actually do the Argand diagram, you know you're going to get something like this. You're going to get just roughly one like that, then like that, then like that, and like that. Roughly equally spaced. That's not brilliant the way I've done it. So the one with the smallest positive argument is going to be this one. So we're calling this one W, this one's 1, this one's W squared, W cubed, W to the power of 4. I need to show that that's true. And I can show it's true because if I do Z equals cis 2 pi over 5, well then Z squared is equal to cis 2 pi over 5 times 2. Okay, I'm just using demoivre's theorem, which is cis 4 pi over 5, which is the next root. And again, I can do this. I can do the same thing. If I cube, I'm timesing by 3, so I get 6. If I'm doing Z to the power of 4, multiply by 4, I'm getting 8. So you can see that if this one is W, this one is W squared, this one is W cubed, and this one is W to the power of 4. So I've shown that. Okay. Now, simplify those brackets there, and hence show that this is 0. Now remember what you were actually trying to find out in the first place. You're trying to solve this equation here. Okay. Now let's just expand and simplify 1 plus W squared plus W cubed plus W to the 4 times 1 minus W. What do you get? You're going to get 1 plus W squared plus W cubed plus W to the 4 minus a W squared minus a W cubed minus a W to the 5, so to the 4 minus a W to the 5. You're going to end up with 1 minus W to the power of 5. Okay, and so this actually is the same thing. So we can basically say that if I let this be equal to 0, we're actually solving the same equation. Okay, so that means that if that is the case, then 1 plus W squared plus W cubed plus W to the 4 times 1 minus W must be equal to 0, because all of this is 1 minus W to the 5, and if we're doing roots of unity, 1 minus W to the 5 must be equal to 0. Okay, I hope that makes sense. Also means 1 minus W is equal to 0. Now, show by vector addition that it's true as well. Well, I'm not going to do this because I haven't bothered to actually work out. Oh my God, I've done it again. I didn't bother to actually work out what these values were. Okay, but if you added all of those complex numbers, so 1 plus whatever this is, plus whatever this is, plus whatever this is, plus whatever this is, it will come to 0. And why is that the case? Well, if you do all of these vectors top to tail, so I'm just going to do it here. So I'm going to move that's W to the power of 2, W to the power of 3, W to the power of, so I've got 1, W to the power of 3, W to the power of 4, and then back again. Oh, I'm making a right mess of this. Let me explain it again. Right, let me get my Argon diagram. And then here are my solutions. Okay, roughly like this. Okay, this one we've established is 1, this is W, this is W squared, this is W cubed, this is W to the power of 4. Remember, if I add vectors, then it's the same as making them top to tail. So I start from here, and I go on this vector here, add W, which is this vector here, add W squared, which is this vector here, add W to the power of 3, which is this vector here, and add W to the power of 4, and you get back there. Basically makes a pentagon where you arrive back at the same point. So that just shows you that you've moved nowhere, so your resultant vector is nothing. Okay, so it's equal to 0. So if you add these values that I've asked you to work out yourself, it will equal 0. Okay, so that's roots of unity.